So now we're ready for example 3. And as you look at the directions for example 3, they say evaluate G composed with F of 2 using the following values. Not rules, values. So that means then that unlike example 1 where they told us that G of X was equal to something and F of X was equal to something, this time they're only going to give us numbers. So how in the world are they going to give us just numbers? The answer is they're going to give us an XY table. So thinking about XY tables, we'll have a column called X. And traditionally when you make an XY table, you would come over here and say, we're also going to have a Y. However, thinking about what's running around in this problem, I actually have two different functions. So I'm going to have Y values that come from the function F, and I'm also going to have Y values that come from the function G. So in fact, on this particular problem, instead of saying that we have an XY table, we're going to have an XYY table. We're going to have two different Y columns. So one of those Y columns is going to be the results that come from the function F, and the other Y column, those are going to be the results that come from the function G. So this is just an extension of an XY table. It just happens to have three columns, but the same information applies. So if I come in and tell you that the X value is 1, then over here I can write down F of 1. Well, F of 1 is going to be the number 3. And then here, once again, this is another Y, but my X is still 1. So this is G of 1, and G of 1 is going to be the number 0. Well, I'm also going to have another row. So let's have another X value, 2. I'm going to plug that X value of 2 into my function F, and I get a number 1. Plug that X value of 2 into the function G, and I get the number negative 3. So on this particular problem then, the author starts by giving you this table. He doesn't tell you the rule for F. He doesn't tell you the rule for G. He simply says, if I plug the X into this function F, I'm going to get an answer of 3. And if I plug this X into the function G, I'm going to get the 0. So even without a rule, we can still do this problem. And it goes back to some of the ideas we talked about in example 1. So let's go ahead and see what we see. We have G composed with F of 2. I'm going to use the same ideas we did in option 2 when we were calculating some of the problems in example 1. I'm going to come in and say, this has a definition. This is G of F of 2. And now that I have that, once again, functional notation is the same as the order of operations. I start on the inside and work my way out. So I have an F of 2 on the inside. Well, as I look at my table then, I have to think about which piece in this table is going to be applicable. So I have an X value of 2 sitting there. My X value of 2 is hanging out right there in my bottom row. So I'm giving this X value of 2 to the function F. Well, if I give it to the function F, this table tells me that the corresponding Y value is 1. So I can make that substitution and say that F of 2 is exactly the same as this number 1. So now that I've done that then, I've made my problem a little bit simpler. Now instead of G of F of 2, this is now just G of 1. Well now as I look at this particular problem then, we have a function G and we have an input value of 1. So this means then that we have an X value of 1 this time. So, okay, X value of 1, that's on my top row. X value of 1, but I'm giving it to the function G. So I need to come over here to my G column, and when I plug in an X value of 1 into the function G, I get a Y value of 0. So G of 1 is the number 0.